Hello and welcome you all. Let's start our discussion and solve question paper of CUCET 2019. In the first two part, we have completed up to question number 55. So in this video, we will start from question number 56. Question number 56. For a radioactive nucleus, the mean life is capital T. If the number of decays per unit time is small n at t equal to 0, the number of decays between time t equal to 0 and time small t is. At t equal to 0, according to the question, the number of decays per unit time equals to n exponential minus lambda t. And we know decay constant lambda equals to the reciprocal of mean life. Here it is capital T. So we can write n exponential minus small t over capital T. Now we have to find number of decays between time t equal to 0 and time t. So from here dn equals to n exponential minus small t over capital T dt. Now take the integration. So dn at initial ni nt equal to n exponential minus t over capital T dt 0 to t. So from here number of decays ni equals to n exponential minus t over capital T minus 1 by t limit from 0 to small t. So it is equal to minus nt exponential minus t over capital T minus exponential 0. Now this is equal to nt 1 minus exponential minus small t over capital T. So your correct option is option C. Question number 57. A nucleus having mass number 240 decays by alpha emission to the ground state of its daughter nucleus. The Q value of the process is 5.26 mega electron volt. The energy in mega electron volt of the alpha particle is. So mass of the parent nucleus is given. Q value of the alpha decay process is given, and we know for a alpha decay process kinetic energy of alpha particle is given by a minus 4 over a times q value of the nuclear reaction. So use that formula. So kinetic energy of alpha particle equals to a is 240, so 240 minus 4, 236 over 240, Q value 5.26 mega electron volt. So now calculate it, and it is equal to 5.172 mega electron volt. So your correct option is option B. Question number 58. The angular momentum and polarity of the oxygen nucleus according to the cell model of the nucleus is. We have to find the angular momentum and polarity for this given element 8 or 17. Here Z is 8 and number of neutrons n equals to 9. So it is, this is even, n is odd, so it is a even odd nucleus. So to find the angular momentum for this nucleus, we have to check to which subcell the last unpaired neutron or the last unpaired nucleon is going. So to check this, let us write the splitting of the subcell according to the cell model. Now splitting of subcells, and it is given by 1s half 1p 3 by 2 1p half 1 d 5 by 2 2s half 1 d 3 by 2 एंड तो देखो इतने में ही आ जाएगा हमारा। तो देखो कि ये स्प्लिटिंग ऑफ सबसेल कैसे याद रखना है वो मैं क्वेश्चन के लास्ट में बता दूंगा, ठीक है। तो जैसे कि देखो अभी ये आ गया स्प्लिटिंग ऑफ सबसेल, तो लेट अस यूज दिस। देखो हमें बस ये न्यूट्रॉन्स के लिए चेक करना है क्योंकि ये ऑड है, ये तो इवन है, तो हमें यहीं से हमें लास्ट अनपेयर्ड न्यूट्रॉन को चेक करना है। जैसे कि देखो 1s हाफ है, तो यहाँ पर कितना आएगा न्यूट्रॉन, देखो ये हाफ है ना, तो कैसे चेक करना है कि यहाँ पर कितना न्यूट्रॉन जाएगा, तो वो 2s प्लस 1 फॉर्मूला यूज करना। जैसे कि देखो यहाँ हाफ है ना, तो 2 इंटू हाफ प्लस 1 दैट विल बी 2, सो हेयर इट विल बी 2 for 3 by 2 here it will be 4 and for half it will be again 2. Now देखो 2 plus 4 plus 2 8, we have total 9 neutrons, so in the next subcell it will be 1, so the last unpaired neutron is going to this D subcell and here it is 5 by 2, so our angular momentum J equal to 5 by 2 and the parity is given by minus 1 to the power L, and this L is for right for this subset D, and for D S P D, so L is 0 1 2, so for D it is 2 minus 1 to the power 2, that is equal to plus 1, so our angular momentum in parity 5 by 2 plus. So now check your option। देखो ऑप्शन कोई भी मैच नहीं कर रहा है, लेकिन ये जो राइट आंसर है ना, दिस इज द करेक्ट आंसर, ओके, फॉर दिस ऑक्सीजन 8 और 17। तुम कोई भी एग्जाम्पल लेके कोई भी बुक से चेक कर सकते हो, दिस इज द करेक्ट आंसर। तो अभी देखो बस ये कैसे याद रखना है, जैसे कि स्प्लिटिंग ऑफ सबसेल एक क्यूट सा लाइन है, बस उससे याद रखना है, ठीक है। जैसे कि देखो द लाइन इज sports if pog dish of pig, ये याद रखना है बस कि sports if pog dish of pig, it means eat potatoes if pork is bad। तो देखो क्या करना है, ये लाइन लिखने के बाद याद रखना, रिमेंबर दैट यू हैव टू एलिमिनेट द vowels from this line, so eliminate u, I, o and keep this last vowel. So now your formula is sp ds f p g d s h f p I g. Now from here you can write 1s half 1p 3 by 2 1p हाफ। अच्छा ये याद रखना, एस यहाँ एक आएगा, पी यहाँ आएगा, तो 1d 5 by 2 2s हाफ 1f 7 by 2 2p 3 by 2 1f 5 by 2 2p हाफ, बस ऐसे करके वो सारे याद रख लेना। Question number 59. If the ratio of the concentration of electrons to that of the holes in a semiconductor is 7 by 5 and the ratio of the current is 7 by 4, then what is the ratio of their drift velocities? Ratio of concentration of electron to that of hole is given, that is 7 by 5, and ratio of their current is given. Now we have to find ratio of their drift velocities, that is drift velocities of electron to the drift velocities of hole. In semiconductor we know that current due to electron is given by NEA VD, that is N is the concentration of electron, E is the electronic charge, A is the surface area of the semiconductor, VD is the drift velocity of the electron. Similarly current due to hole is given by PEA VD. P is the concentration of hole, E is the electronic charge, A is the surface area of the semiconductor, Vd is the drift velocity of the holes. So IE over IH equal to N by P PdE by VdH. So now use the given value and find the result. So ratio of their drift velocity is equals to IE by IH times P by N. So that is equal to 7 by 4 into 5 by 7, or it is equal to 5 by 4. So your correct option is option D. Question number 60. If a semiconductor has an intrinsic carrier concentration of 1.41 into 10 to the power 16 per meter cube, when doped with 10 to the power 21 per meter cube phosphorus atoms, then the concentration of holes per meter cube at room temperature will be. Concentration of intrinsic carrier concentration is given, and concentration of phosphorus atom is given. And we know that phosphorus atoms are pentavalent atoms. So the given concentration will be taken as concentration of electrons, that is N equal to 10 to the power 21 per meter cube. Now we have to find the concentration of holes, and from laws of mass action we know that Ni square equal to Np. So from here concentration of hole, that is P, equal to Ni square over N. Now use the given value. So that is 1.41 into 10 to the power 16 square over 10 to the power 21, and now calculate it. It is equal to 1.988 into 10 to the power 11 per meter cube. Or now check your option. It is equivalent to, you can take 2 into 10 to the power 11 per meter cube. So your correct option is option B. Question number 61. An electronic oscillator gives sustained oscillations when the feedback is. So देखना ये क्वेश्चन बहुत बार रिपीट हुआ है, हमने CUCET 2020 और CUCET 2017 सब में डिस्कशन किए हैं, ठीक है ना. तो ये याद रख लेना कि एन इलेक्ट्रॉनिक ऑसिलेटर गिव्स सस्टेन्ड ऑसिलेशन विथ पॉजिटिव फीडबैक एंड इन फेज विथ the input, and in phase with the input. So your correct option is option D. Question number 62. If the peak output voltage of a full wave rectifier is 10 volt, its DC voltage is. Peak output voltage of a full wave rectifier is given, and we have to find DC voltage for that full wave rectifier. And we know in a full wave rectifier the DC voltage is given by 2 Vm over pi. So now use the given value. So 2 into 10 by 3.14, so which is equals to 6.36 volt. So your correct option is option C. Question number 63. When a transistor amplifier having current gain of 75 is given an input signal Vi and the output signal is found to be this V0, the transistor is connected as. So input and output signal of a transistor is given. So to check whether the transistor is in common base or common emitter or common collector connection, so just calculate the phase difference between the input voltage and output voltage. So from here the phase difference between the input voltage and the output voltage is 3 pi by 2 minus pi by 2. So that is equal to pi. So the phase difference is pi. As the phase difference is pi, so the transistor is connected as common emitter amplifier. So your correct option is option C. Remember that the phase difference between the input and input voltage and the output voltage for common base and common collector is 0 degree. For common base and common collector, the phase difference is 0 degree. So here it is pi. So this transistor is connected as common emitter. Question number 64. The Fermi level of an intrinsic semiconductor is at the center of the band gap. The probability of occupation of the highest electron state in the valence band at room temperature will be. We know according to Fermi-Dirac distribution, the probability of occupation of the electron state is given by 1 by 1 plus exponential E minus EF by kBT. Now we have to find this probability at room temperature, that is T not equal to 0, and we have to define this for highest electron state, that means E equal to EF. So f of E equal to 1 by 1 plus exponential 0, that is equal to 1 by 1 plus 1, or it is equal to 1 by 2. So your correct option is option C. The probability of occupation of the highest electron state in the valence band at room temperature will be high. Question number 65. The Boolean expression is equivalent to. So we have to simplify this given Boolean expression. Let y equal to this, and देखो ये पूरा जो expression है ना उसका complement given है, तो क्या करो कि use the De Morgan's theorem. We know that from De Morgan's theorem, a plus b complement equal to a complement b complement, and second statement is that कि a b complement equals to a complement plus b complement, and also we know from Boolean theorem is that कि a bar equals to 0, a plus a bar equals to 1. So use them. Now this y equals to ab bar dot a bar dot ab bar, and also we know that a bar equals to a. So this is equal to ab dot a. Now ab complement, so use this statement, that is equal to a complement plus b complement. Now a times a equals to a, so it is ab a bar plus b bar. Now this is equal to ab a bar plus ab b bar. Here a bar is 0 and b bar is 0, so this is 0 plus 0 equals to 0. So your correct option is option D. Question number 66. If the output of a logic gate is 0 when all the inputs are at logic 1, then the gate is either. देखो ये जो ऑप्शन में जितने सारे गेट है ना, तो सारे गेट के लिए एक बार चेक कर लो, जैसे कि फॉर NAND गेट, let us consider 2 input NAND gate. So this is our NAND gate. Now when inputs are 1, so 1 1, so output will be 1 1 complement, that is 1 complement equal to 0. So when all the inputs are 1, its output is 0. Now let us check for NOR gate. Consider 2 input NOR gate. This is OR with bubble. Now it is NOR gate. Now inputs are 1 1, so 1 plus 1 bar, that is equal to 1 bar, that is equal to 0. So for NOR gate, output is also 0. Next, check for XOR gate. XOR gate. Now inputs are 1 1, so output is 1 bar 1 plus 1 1 bar, that is equal to 1 bar is 0, so 0 times 1 0 plus 1 bar 0 0 times 1 0, so output is 0. Now let us check for XNOR gate. देखो ये तो पता ही चल रहा है कि XNOR गेट की आउटपुट 1 आएगा, क्योंकि output of XNOR gate is complement of XOR gate. So now we can check 1 1, its output will be 1. So the logic gate is either XOR or NOR, for which when all of its input are high, output will be 0. So your correct option is option C, the gate either XOR or NOR gate. Question number 67. In order to obtain a solution of the differential equation involving voltage V and V1, an operational amplifier circuit would require at least, we have to find solution of this differential equation using operational amplifier. Now देखो, from this equation we can write d2v by dt square equals to 2 dv by dt plus v1. तो देखो हम ऐसे कंसिडर करो कि हम ये this d2v by dt square using as input and we have to find output as this expression 2 dv by dt plus v1. So देखो from d2v by dt square we have to find dv by dt. तो देखो मैथमेटिकली कंसिडर करो कि ये कैसे आएगा. वी हैव टू डू द इंटीग्रेशन, सो वी हैव टू यूज 1 ओपम h ओपम इंटीग्रेटर. सो वी हैव टू यूज ओपम इंटीग्रेटर. देखो जैसे कि minus plus, this is grounded. Now let it to be C. Here we are giving d2v by dt square. Now as it is a integrator circuit, it will give us dv by dt. So next, in output we have to find total this expression 2 dv by dt plus v1. So to get this we have to use an adder circuit. So let us draw an adder circuit. Minus plus, this is grounded. Now this is v1 constant voltage, this is the feedback. Now here output. तो देखो ये यूज कर लो, जैसे कि इसको R1 ले लो, C ले लो, R2, R3, R4. तो देखो फाइनली हमें यहाँ क्या मिल जाएगा dv by dt प्लस v1 एज इट इज एन एडर सर्किट. सो देखो ये जो 2 है ना, यहाँ कोफिशिएंट 2, देखो हम ये R2 और R4 की रेशियो ऐसे डिफाइन करेंगे और ऐसे यूज करेंगे जैसे कि हमें ये कोफिशिएंट भी में आएगा साथ में कि 2 dv by dt प्लस v1. तो देखो फाइनली टू फाइंड दिस एज आउटपुट फ्रॉम d2v by dt स्क्वायर वी नीड 1 op amp इंटीग्रेटर एंड 1 op amp एडर. सो वी नीड 1 op amp integrator and 1 op amp edge adder. So your correct option is option C. Question number 68. The common mode rejection ratio of a differential amplifier using an operational amplifier is 100 dB. The output voltage for a differential input of 200 microvolt is 2 volt. The common mode gain is. We know common mode rejection ratio CMRR is given by ratio of differential voltage gain to the common mode gain, and CMRR in dB is given by 20 log base 10 AD by SCM. So from here 20 log base 10 AD by SCM equal to 100, or from here log of base 10 AD by SCM equals to 5. Now from here AD by SCM equal to 10 to the power 5. Now SCM common mode gain equals to AD by 10 to the power 5. Now according to the question, differential gain AD is given by output voltage 2 volt over input voltage 200 microvolt, or that is equal to 2 by 200 into 10 to the power minus 6, or that is equal to 10 to the power 4. So common mode gain equals to 10 to the power 4 by 10 to the power 5, that is equal to 0.1. So your correct option is option B. Question number 69. If the wavelength of the first line of the Balmer series in the hydrogen spectrum is lambda, then the wavelength of the first line of the Lyman series is. We know for hydrogen spectrum wavelength is given by 1 by lambda equal to R infinity 1 by nf square minus 1 by ni square, where R infinity is the Rydberg constant, value is 1.097 into 10 to the power 7 meter inverse. Now for Lyman series, NF equal to 1, that is a transition takes place from higher excited orbit to fast orbit, and for the first line of the Lyman series Ni equals to 2. So 1 by lambda, let it to be lambda L, first line of Lyman series equals to R infinity 1 minus 1 by 4. From here lambda L equals to 4 by 3 R infinity. Now according to question, we have to express this term in terms of wavelength lambda. Now next let us calculate for Balmer series. For Balmer series, NF equal to 2, transition takes place from higher excited orbit to second orbit, and for first line of Balmer series Ni equal to 3. So for wavelength of first line of Balmer series is given by R infinity 1 by 4 minus 1 by 9. From here lambda wavelength for first line of Balmer series is given by 36 by 5 R infinity, and according to question this is equal to lambda. So now we have to express this lambda L in terms of this lambda. So now wavelength of first line of Lyman series equals to 4 by 3 R infinity, that is equal to, or this is equal to 4 by 3, देखो 1 by R infinity equal to 5 lambda by 36, which is equal to 5 by 27 lambda. So your correct option is option B. Question number 70. The electric field of a light wave is given by this expression. The polarization state of the wave is. The electric field is given. We have to find the polarization state of the wave. And from the given expression, we can check that the phase difference between x and y component of electric field is pi by 4. So the electric field is elliptically polarized wave. Now we have to check whether it is left-handed or right-handed. So for this we have to check the variation of tip of the electric field with time. So to check this, let's consider z equal to 0. So electric field E will be E naught I cap sin omega t plus j cap sin omega t minus pi by 4. Okay, so let's take at t equal to 0. Now we have omega is equal to 2 pi by t. So at t equal to 0, electric field vector will be equals to, देखो ये तो 0 हो जाएगा, sin 0 0 and sin minus pi by 4. So minus j cap E naught by root 2 at time t equal to 0. Next check for time t equal to t by 4. At time t by 4, electric field will be equals to, देखो ये हो जाएगा pi by 2. So sin pi by 2 1, here pi by 2 minus pi by 4, that is pi by 4. So equals to E naught I cap plus j cap by root 2. Now let us check for another time t equal to t by 2. Electric field vector equals to, देखो for t by 2 it will be pi sin pi 0. Now sin pi minus pi by 4, that is 3 pi by 4. So E naught j cap by root 2, this direction. So now draw the tip of the electric field vector. At time t equal to 0, let this is I cap j cap minus I cap minus j cap. At t equal to 0, electric field vector is minus j cap E naught by root 2. So that is in this direction, minus j cap. Okay, at t equal to 0. Now at t equal to t by 4, जैसे ही टाइम इंक्रीज कर रहा है तो देखो ये कहाँ आ गया कि E naught I cap plus j cap by root. Okay, at t equal to t by 4. Now at t equal to t by 2, it is along this j cap. At t equal to t by 2, so it is rotating anti-clockwise direction, in anti-clockwise direction. So it is left-handed. So the given electric field vector is left-handed elliptically polarized light. Left-handed elliptically polarized light. So your correct option is option C. देखो जैसे कि हमने फर्स्ट लाइन में क्या डिफाइन किया कि इफ द फेज डिफरेंस बिटवीन एक्स एंड वाई कंपोनेंट इज पाई बाई 4 देन दैट इज एलिप्टिकली पोलराइज्ड लाइट. सो इसे याद रख लेना कि फेज डिफरेंस कंडीशन क्या होना चाहिए. देखो जैसे कि इफ फेज डिफरेंस बिटवीन ई एक्स एंड ई वाई इज even multiple of pi by 2. If the phase difference between x component of electric field and y component of electric field is even multiple of pi by 2, then the given electric field vector will be linearly polarized light. Now if the phase difference between x and y component of electric field is an odd multiple of pi by 2, then the given electric field will be circularly polarized light if the amplitude are equal, and if the amplitude are unequal, then that will be elliptically polarized light if E naught x not equal to E naught y. And one more condition is that if the phase difference between x and y component of electric field is other than the above defined condition, other than the above defined condition, above, then the given electric field will be elliptically polarized light. And for right handed or left handed, you have to check how it is rotating, clockwise or anti-clockwise. If clockwise, then that will be right handed. If anti-clockwise, then that will be left handed. So in this video we have completed 15 questions. So we will continue in the next video. Thank you for watching and all the best for your exam.